notes about coordinate geometry. Now, I've got a funny feeling some of the questions that you've just been doing may have involved algebra. And perhaps should have carried on yesterday, but I felt you could on anyway. And so sometimes these questions are going to involve algebra. So if they do, you're just going to use your geometrical knowledge to form an equation. So what do we know about these angles in this diagram? Erin?
They all equal. They set up to equal 180.
Yeah, so they add up to give 360. They add up to give 360. So I would write 4x plus 2x plus x plus 5x is equal to 360. Okay? So I've used my geometrical knowledge that I know these are angles at a point. I know that they add up to give 360. So I formed myself an equation. Okay? Now, this equation here, how would I solve it? I've got lots of x terms here. What do we do to solve an equation, Julia?
You add the x terms together.
Yep, so what would I have?
It'd be 6x plus x, 7. 7 plus 5, 12. So it'd be 12x equals 360.
And then,
30. X equals 30.
how do you do that?
You divide by 12, divide by 12.
Okay, trust the ends? Then obviously if they've specifically asked you about any of those angles, you would then answer it. So sometimes the question might say, tell me what each of the angles are. So if you've established that x is 30, it means that this one is 30. This one would be what?
30 times,
How'd you get that?
30 times 5.
Yep. And then this one would be,
30 times 4.
which is,
I don't know.
and this one would be,
60.
I can see the two.
you got it in front of you as well. Okay, just the ends? How would I form this equation? Well, what do I do to form an equation for this one?
Well, you do it all and it's on a straight line.
Yeah.
It'd be x plus 90 plus x. And then equals 180.
Or, isn't it?
Yeah.
Okay, so my equation is that it's equal to 180 because I've added them. And obviously the square box tells us that one's 90. Join like terms and simplify, so we've got 3x plus 90 is equal to 180. Solving that equation, we would do what?
Minus
You gotta take away 90 from each side.
Yeah.
So then you have 90 on one side, and then you have 3x, you have to divide by 3.
Nice.
30, right?
Okay, just so happens to be 30 is okay. Pretty straightforward. Similar thing here. We've got 8x plus 70 is equal to 180. So 8x plus 140 is equal to 180. 8x is equal to 40. X is 5. Okay. 15 plus 45 plus 3x is equal to 180. 60 plus 3x is 180. 3x is 120. X equals 40. Okay, hopefully they are very doable. And you're like, seriously? Why are you going to do this? Okay. I'll just let you finish those. I'll just pause for 2 seconds. There's never the right or wrong time to do this, so just making sure you remember all about triangles. So an equilateral triangle has got 3 equal angles, 3 equal lengths. And you'd show the equal lengths with some kind of marking. What do we know about the angles in an equilateral triangle? Good, they're all 60. How do you know they're all 60?
Because they all add up to 180.
Good, okay? So the angles are always 60 degrees in an equilateral triangle. Okay, so it's never going to be anything other than that. An isosceles triangle, we talked about these last lesson, so we've got 2 equal lengths, 2 equal angles. These angles here would be the equal ones, because they are considered the base angles. Okay? A right angle triangle obviously has 1 right angle. Okay? And there's nothing else special about it.
Pythag.
Yep. Well, Pythag, and also we've done. Have we done trivial?
Well, we did it last year.
Oh, you did trig last year?
Yeah.
So, so.
Yeah.
Like stack it.
Okay, so Pythag and trig both are to do with right angle triangles. They're not always going to put a big flashing light, but just look out for the square symbol anyway. Scalene triangles. So this is the one that sometimes people forget what these are called. So scalene triangles have no lengths equal, okay, and none of the angles are the same either. Okay, so it may look like a right angle triangle, it may look like an isosceles triangle, but do not assume things. Okay, so remember what I said about the questions. They will normally have something written next to it saying not drawn accurately. Okay, so do not assume anything when you look at stuff. You may have a right angle isosceles triangle. Okay, what's special about that is it has a right angle, but these two lengths are equal. Okay, so if those two lengths are equal, where would my base angle be?
The other two angles.
The other two. And what do we know about the other two angles?
They're the same.
They're the same, which means they must both be what?
8.
60.
No,
45.
Nice. Okay, so for a right angle isosceles triangle, you will always have two angles of 45 and an angle of 90. Okay, just getting you to think about that again. We know the angles in any triangle add up to 180. We know that this is a right angle, that these three have to add up to 180, which means these two add up to 90, which means they must both be 45. Okay, makes sense? So if you ever see a 45, 45, 90, you know it's an isosceles triangle. Quadrilaterals. Oh no.
Review of triangles.
Review of triangles again. Jeepers creepers. We talked about this. La 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 la. So how would we find this one? We know there's equilateral triangles, so we know they're all 60.
Yay.
But
Okay. 60, 80. How are we going to find D?
you do 80 plus 60 and then 80 minus that.
Yep. So 80 plus 60 is? Good mental maths is what I'm thinking. Okay, so D is 40. Okay, part 3. Don't remember we normally do this alphabetical order, so E we can say straight away is 40, and F would be
180 minus 80, which is 100.
Okay. You've got the top one 30. What do we know about the other two?
That they're the same.
They're the same, so we know that 180 subtract 30
Equals 150. So
And so
then
how do we find G and H?
you divide by 2, and then they both equal 75.
Oh, we are awesome.
Wait, what are we doing? Wait, I'm confused.
Finding H and G. G and H.
Oh, there's
Haley
the
Graham.
right?
Wait.
Yes.
Oh, so you do
Haley and Graham.
so you do 180 minus 30 equals
We do 180 subtract 30. So we know the angles in a triangle are
Haley Graham.
We know this is 30, so that means the other two have to add up to 150. Yeah.
Yeah.
In the car.
And this last one, we've got this is 90, this is 45, so this
45.
must also be 45. And that's a prime example of one that isn't drawn accurately, because that really, these two lengths do not look anything like each other, but they must be the same, so we know it must be nice.
But it doesn't have the two little equal signs.
Exactly, so that's what I said. Even if lengths are equal to each other, they don't always put it, okay? Because if they put it, then they've given too much away.
But then how
They
would
will
you
put
know
it
that?
if you need to know that. Okay?
But wouldn't we need to know that for this one?
No, because
No, because you know that the angle
Oh,
in the triangle add up
yeah.
to 180.
True.
Yeah?
True.
So if it's necessary, they will put it. But for example, if an angle may turn out to be a 90-degree angle, but they
Yeah.
won't have put the square thing in.
Yeah.
But if you calculate it, it could be 90. Okay? Right, angle and quadrilateral. What's the shape called? Okay, we know the four angles in this quadrilateral are.
That's correct.
Yeah, because I can't be bothered to write an angle.
are you tired, Miss Harrison?
A little bit. Only did two. 2. Well, for me it's day 3, but anyway,
Why is it
we start on Monday.
Oh, for you. Hey.
What do our angles in the quadrilateral, what's that up to?
360. I got it first.
Is it true for all quadrilaterals? Yes, basically it is. How can we show that? Well, in any polygon. We've heard the word polygon before?
Yes.
Yes, so polygon is the general name for any shape with straight sides. So poly means many. So this particular one is a quadrilateral. It's an irregular one. But what you could do for any...
Wait, so is a circle a polygon?
no, that doesn't have straight sides.
Yeah. What is it?
It's a circle. Circumference.
No,
I don't know, but
that's
like, what's
that. Yeah.
there's no like specific name for
No,
it?
it's just a circle.
A non-polygon, maybe?
Sure.
Polygon.
Not polygon.
Not a polygon.
Have you guys not heard that non-polygon?
No, darling, I don't mean
Polygon.
Let me kill the
Polygon.
Okay, I don't mean to be highlighting this, but this is being recorded, and so people are just going to know that you said that.
There's
Julia Slade, Bermuda.
there's such
2020.
Southampton.
Brother to college.
There's such thing as hey.
They look like twins.
No, they don't.
Anyway, so for any polygon, you can establish what the angles in the shape add up to. What have I done here by drawing this diagram?
You made two triangles.
Made 2 triangles. What do I know about this angle, this angle, and this angle?
They're all sum up to 180.
And what about this one?
They'll
This
sum
one?
up to 180.
Okay, so we've got 180 total here and 180 total here. Have I covered all of the outside, all of the angles here?
Yeah.
Yeah. So that means that my total has to be 360.
360.
Okay. Now, if I had a 5-sided shape, okay, doesn't have to be regular. I could do the same thing. I could cut it up into,
3 triangles.
this time it would be 3 triangles. Again, we could say that these angles all add up to 180, these add up to 180, these add up to 180. So the angles in a 5-sided shape would all add up to 540. Okay? So if you're ever asked about the interior angles of any polygon, you can always do this to establish how many and what the total would be. Do I side note here? But what?
I'm confused.
Why?
No, I'm just confused. Why?
Confusing.
Like, why are you splitting it up and saying that?
Because I want to know the total of the angles in the quadrilateral.
Right.
And so to do that, what I've done is I've established that I've covered all my basics. By doing those 2 triangles, I've dealt with all of the 4 angles in that shape.
Do you have to connect the little vertices when you're doing this? Is that what they're called, vertices?
Yes, to cut it up, yes. You wouldn't just randomly draw a line like that,
Okay.
because that wouldn't help.
Or could you just do one vertice?
Because then you wouldn't
like
have 2 triangles.
Right.
Yeah, so to get the triangles, you'd have to go from point to
Vertices.
Is that what they're called, vertices?
Yeah, that's
Great.
Good job.
Is that what you were trying to establish?
Yeah.
Sorry. Okay, so the sum of any quadrilateral is always 360. So if we had this shape here, how would we find B?
You add up all the angles given, And then you and then you do 360
Minus that number, which equals B.
Pardon?
Minus.
X
shall equal 120.
Okay.
Wait, 70.
Lesbians?
Lesbians.
Oh, we've got another one?
Oh, wait.
Whoa.
Okay, opposite angles of the parallelogram.
They're
They're
equal.
always going to be equal, okay? Remember, this is, sorry, I shouldn't have said that. This is a parallelogram, yes? So this is where we have 2 pairs of parallel sides, okay? So these ones here are both 60. Now, remember we talked about parallel lines yesterday. What do we know about, how would we describe these angles?
They're No,
It's
they're
C.
coefficient. No.
Co-interior. Okay, so co-interior angles, what's special about them?
They're both out to 180.
Good. So this one here must be 120.
120.
And we know that these are the same, so they would be 120. And we would double check that they all add up to 360, which they do.
Oh.
Fabian?
Miss Harrison, I did this one already.
Oh, good girl.
And I did all the other ones before.
You are amazing.
A star.
Well done.
We're not hell.
All right. Do we know the rule about the exterior angle and triangle? Have you ever learned this?
No.
Okay. So if here you see we've got this triangle here. What I've done is I've extended this line. Okay. This angle here will always be equal to the sum of the two angles opposite it. Okay, so this is going to be equal to 30 plus 100. So y is equal to be is going to be equal to 130. So the exterior angle is always equal to the sum of the two interior ones opposite it. Now, when I say exterior angle, you have to be careful that you are extending one of the lines to form a straight line. Now, you may say, well, why on earth is that? 1 second, Gabby. So, I could find this angle here by doing 180 subtract the sum of these two, yes? So, I would get this angle here as being 50. Well, what do I know about these angles here? They're on a straight line, so I know that they have to add up to 180. And so that has to mean that this angle here would be 130. And that's why, because we've got these two here in this calculation, and then just this one in this calculation, that's always going to be equal to the sum of those two. All right? So if you forget that rule, it's not the end of the world, because you can always do it in the slope, the angles on a triangle, and then the angles on a straight line. But if you do it in that format, you have to give both of those two reasons. So if any calculation you're finding in an angle that they haven't asked for, you need to give the reasons for all of the angles you're finding. Okay? So that one here with the rule is, or the reason would be exterior angle in the triangle. Gabby, what was your question? Oh, check me out. Okay. So the external angle would always, in this case, would be equal to A plus B.
May I please go to the bathroom?
Go to this angle?
Thank you.
Oh, I guess it is. Okay.